Hi, my name is Brian Masuda. I'm from Ennead Architects.
And Amy Milky, also with Ennead Architects.
So I think, as Omar has mentioned, he's grouped sort of some of the projects by subject matter or what they're exploring. And so it's kind of interesting because not only does the Danish team and our Ennead team share the idea of water and how facade can address the water or use water to make people more comfortable, but we also have a very unnamed that's often mispronounced. So just a reminder, our name is Ennead, but we're very excited to be here. This is our first year at ACAW, and like many have expressed, when we've seen the previous studies that came out of here, we thought we definitely have to get involved, and it has not disappointed us. Next. So there were three of us here for the build: Ayumi, myself, and Amy. Unfortunately, Ayumi had to leave to address something back home. But what we wanted to point out was that beyond the three of us, there was obviously a lot of people involved. It took a village, and we purposely did that. We have a very collaborative approach to design. We think the more voices there, the more specialties, the more points of view that come in, the more rich the exploration will be. And we've seen that in every single event or discussion that's part of ACAW, whether it be the academic groups sharing their work, the casual conversations that have happened between events. It's all been very rewarding, and I think it's very affirmative.
Yeah.
So we want to start as a team and ask ourselves what inspires us about terracotta, and what are we going to look at as we start to investigate our design exploration. We wanted to look at things such as functionality, shape, the idea of a vessel. These vessels are usually load bearing. There's so many opportunities for different types of finish, whether it be texture or glazes. And sort of the idea of the craft, the hand, like what about terracotta makes you feel so connected to it? It's the earth, but it's also the fact that it looks like it's been sort of in an artisan feel. And I guess I wish we could also add the Guarantee building onto this, and also the Boston Valley Terracotta plant, which we really enjoyed that tour, and it was very inspiring for us as well. As drivers, we wanted to make sure that our study was also a holistic approach. Environmental performance, embodied carbon. All these things have to come into play. So in the performance category, we looked at these things such as natural ventilation, evaporative cooling, solar shading, daylighting, and views. We got to the fabrication component. We wanted to make sure it was scalable. It could be something that could actually be implemented onto a project. We wanted to, again, minimize embodied carbon. We'll show you how we did that as we go through the details. We wanted to make sure that we were reducing weight as much as possible, and through material optimization. And the last thing was we wanted to make sure that it was a product that could have versatility to it, so that people who used it, designers, they could modify it, the system, to create sort of a range of design expressions, and whether that's through porosity, the surface texture, surface finishing, or the geometry itself. We think that was very important for us to incorporate into our thinking. This is sort of our dream of what we thought ACAW was going to be, and it's actually surpassed it. Like I had mentioned with the academic groups, with all the sort of the personal connections, as many people have mentioned. We just wanted to put this in here because this is sort of expresses our gratitude and thanks for being a part of this process. So we're going to talk about our system, which we're calling Eau Soleil, sort of a play on Brise Soleil. And this is our initial image array that we did, our sort of collage, looking outward at things that have already been done, some idea of terracotta and water, dappled light, screen elements, and this is one of the studies that was done from a previous ACAW. So this is really like a visual representation of some of the initial thoughts that resonated in our mind as a team. Then we wanted to look inward. I think that no design exploration is an isolated island in itself. I think this is very evident in some of the teams that have participated multiple years in a row, that their designs are evolving, their explorations, lines of explorations are continuous, and they build upon each other. So in our own work, we have been looking at some projects and some screen walls or screen elements, such as this vertical screen that surrounds a courtyard at the United States Embassy for Ankara, Turkey. And another version here for Apple Scottsdale. how do you put a glass box in the middle of a desert, right? So we developed this UHPC. The Anchor project was also UHPC. This is in the form of a trellis that really extends over the public way and really creates a place for gathering. And you can see the sort of the beauty of the dappled light and the comfort that that canopy is providing. But one thing that we wanted to look at was on the next slide, as I mentioned before, terracotta has such a richness to it. It has the ability for variegation in color, a warmth to it, texture. This is a project that I think some of you are familiar with. It's our University of Michigan Biomedical Science Building in Ann Arbor. And it really uses the extruded terracotta in multiple colors, different angles, different textures to really give you that the sort of biophilic connection to nature. And again, the warmth and the craft that we love so much about terracotta. And then, performance and terracotta. In one of those slides, it was the water and terracotta. And so Amy had some ideas on how water could be explored and integrated into thinking.
Yeah, thanks, Brian. This fourth form is a project that I did with Caitlin Taylor 10 years ago, where we studied material and form as a control for floodwater. And it ignited a real interest in cultural and biological layers of water in the built environment. When we started this process, we approached the design of a terracotta cooling wall with a series of vessels. But the weight and the secondary structural system that it required just didn't align with our goals for efficiency and visual versatility. So we pivoted to previous geometry research from our computation specialists at the office. We realized that a single surface module would give us the surface area, continuity, and repetition that we needed. Erwin Hauer has been a consistent inspiration for us. We use this design for a screen wall at the Standard.
Yeah, it was for the Standard Hotel at the meatpacking. We used it both at the ground level, but also at the roof terrace. And we actually have a couple of these samples sitting around in our office. So maybe it was like subliminal messaging or something and subconscious that led us to start to explore elements that were a little bit more derivative of that type of idea.
The design priorities of the approach are performance-based. We kept saying that the project was the performance. It was the space adjacent to the wall, not the wall itself. And that it was meant to mediate solar impact of the heat gain and mitigate glare. So we'll be efficient with as few components as possible.
Go back one second. Yeah, one thing we wanted to also point out was one of our goals was we wanted the screen to be three-dimensional and viewed from both the inside and the out and have a similar expression from both directions. And so, the cable wall systems are very beautiful, very elegant, but we felt that the stacking of these units allowed us to get a more consistent experience from inside and out.
Yeah, it was a lot of work to get to a point of a single module. A lot of back and forth, a lot of questions from the Boston Valley team of, do you want this to scale? and if so, kind of keep trying. So we came to a tile that would move the water the way we wanted it to, be repeatable, and provide the structural integrity that we needed to be load bearing. And for it to be ram pressed. So it's a simple enough form that we can mill up the form work for the ram, and it will hold its structure in the drying process while sitting on a cradle. So, and dealing with the shrinkage that required, that really governed the entire geometry.
We also had to make sure there were no undercuts. That was a big challenge for us with some of the curvatures and the hyperbolic surfaces. We kept sort of looking at it in both like 3D model, cutting through with clipping planes, just to make sure that there wasn't anything that couldn't be pressed successfully. So as I mentioned, we really wanted to, like the Banish team, we were like, how do you control water flow? it's actually very difficult. But we started off with like different iterations. We thought, okay, what if we just do a smooth surface and make the holes really big? That seems like a no-brainer, right? But it actually didn't work. Everything just sort of kept the water kept sort of shedding off the edges. Then we moved to something more. I think that it's a little bit like the Danish scheme, but it was sort of this ribbed surface that had channels that started to direct the water to the hole. Didn't work. Then we looked at more of a stippled surface, elongated edges, and that's where it started. We started to see that the water started to pool and to be sort of get stuck on the surface. And we thought, okay, we're onto something. And then finally, we ended up with a texture here that really reduced the water flow rate. Unfortunately, and this is something we learned, the pattern that we produced was a little bit too fine. So in the firing process, it sort of melted away, or it kind of smoothed itself out. So, talking to Andrew, it's like if we were going to do this again, we probably want to exaggerate that texture. Designers, we always want everything to be smaller, smoother, but in this case, we should have really amped it up a bit.
Yeah. Yeah. The more textured it is, the faster it will start soaking up the water. But at least the inherent like material friction of the terracotta was allowing it to absorb in a way that the plastic models weren't, really simulating.
Yeah, and so this is where we were just basically trying to optimize the texture. Obviously, we didn't optimize it correctly, but this was our goal at it, and we were really trying to look at how the variation of pattern would really best slow the water flow down. And one thing I want to point out that maybe is not so obvious in the mock-up is that all the faces facing up where the water will flow over are unglazed, and that is because we wanted to maximize the absorption into the unit itself for evaporative cooling, which Amy will talk about in a little bit more detail in a subsequent slide. And all the upper surfaces are glazed because we wanted that to be more of the daylighting reflective surface that would project daylighting into the interior space. This is just more that there's not only the form and the shape of the piece itself, but all of the cradle geometry and the texturing and everything was another level of trial and error in terms of geometry. Again, it had to be something that could actually be fabricated. We also, as Amy had mentioned, and maybe some other teams, the whole shrinkage issue was, I think, maybe we underestimated. When we can talk about a little bit more about when we started to assemble it, but because of the form of our surfaces, the curves, the shrinkage started to become an important consideration. And we were, working with Andy, like the other teams did. We were looking for the right glaze. We wanted something more monochromatic. We wanted something on the upper surface that was really just a glazed version of the textured surface below. This is sort of what the texture we wanted look like in the smaller sort of foot partial mock-up sample that we had. I think it's because it's a smaller piece that texture survived, where as it didn't in the larger unit. We purposely wanted to keep it monochromatic so that as water starts to flow through the wall and it starts to coat the unglazed surface, it's sort of a really poetic sort of transition between the glazed surface. And then you start to see the unit and it actually looks glazed from the water flow that's flowing over it.
This is where you talk about your baccarat.
Oh, no, we'll talk about it when we go to the bottom. One of our applied computing guys back home, Robinson Strong, created a custom custom plugin or custom engine that runs in Grasshopper. I think it's in Python or
I don't know. You
Giraffe.
use
Yeah,
physics something.
one of these things. He's going to scold me for not remembering what that was. But basically, he did a simulation where it dropped these beads of water and it actually showed the pattern of the water flow. So this gave us a level of assurance that what we were doing, at least from a geometry and texture standpoint, would work in the actual prototype. And then I had mentioned earlier that we want to give people variations, right? What we picked was the most efficient shape in terms of its unit and the way that the load transferred. As Amy mentioned, the load bearing issue was something that we really wanted to maintain. So these were where, the load transfer was happening in straight lines. We understand there might be some variation that people want to build into it. So these are some quick tests that we did. It's still 2 units. It's just that you start to rotate them 180 degrees in different combinations. So you could get something that's more like a fan shape profile. There could be more something that's more like an almond shape facing outwards. or maybe it's something a little bit more dynamic where it has a more asymmetrical composition. These were just some, drawings. We really wanted to thank Boston Valley for all the work they did. We wanted to do something a little bit more complicated with our cart because we needed water to be flowing through it. So, we worked with them to come up with sort of a detailed understanding on what this cart would be. And, although of course, like every cart, there's some hiccups, we think it turned out well. Right? And this is just a level of detail we got at. I think when you look at these drawings now, I think we both kind of laugh because the level of tolerance that we have shown, in terms of dimensions, like how much space between those biscuits and the glazing pockets or the pockets that the terracotta units receive them. We've planned for tolerance, we just didn't plan for enough tolerance. And I think one thing that this points out too is, it's like 101, right? Slotted holes for your bolted connections, something we didn't do. So
We needed that.
this series of photos always makes me laugh. It's like a range of emotions, right? The first day, pieces, they're amazing. Like the clay side, everything turned out well. This is where the dread starts to set in, and we started to place them, and it didn't quite fit on the base. It wasn't quite spaced correctly, and we were thinking, how are we going to get to those 7 levels that we need to stack them to? So thankfully, for some of our honorary team members, it wasn't our idea, but Sion from University of Michigan, she was walking around and she joined us, our team basically, and gave us this idea of doing this sort of jig where we clamp the lower levels together so that we could try stack the units up to get to the lateral outriggers that happen above. So that was a real time saver. That took us maybe 3 hours to get to that point, and then the rest of it maybe happened in an hour and a half.
Yeah. Well, and two of her students, Sydney Sinclair and Taylor Douglas, were major helps for the entire process. So maybe she saw the dread in their eyes after 3 hours working at the base.
So these are just some of the photos of the mock-up before we turned the pump on to test the water. The color of the terracotta, we were looking at something that was a little bit more white. We wanted it to be a little bit more washed out, but we used the more tan color just because of the purposes of this workshop. We needed to use the body that was a little bit more efficient. But in the end, when the sun hit it, these pictures look a little bit more yellow than it does in reality. It's really quite beautiful. And you can start to see the idea of, the glossy reflective surfaces versus the matte surfaces at the bottom.
Okay, so the structure of the system is really a collaboration between the geometry and material properties. So the terracotta is performing in compression, which allows it to be a self-supporting lattice. And the stainless steel discs that slot in at the feet are acting as lateral support for the units with stainless steel tiebacks that provide lateral support for the entire system. We call them biscuits, not discs.
Oh yeah, biscuits. Sorry.
It made everybody hungry. Um, okay, yeah, sorry. You can see that the greatest load is at the base, which is why we would have to kind of have a maximum of 2 levels before you would need another shelf and start another series. But the system overall is pretty uniform. The daylighting strategy creates a diffuse interior daylight, allowing visibility through and maximizing indirect light. That's helped by both the geometry, but also the finish. As Brian mentioned, having the glaze on the underside of the units will help it kind of reflect back into the space. The dynamic shape has also really reduced the solar gain in the wall cavity.
Yeah, this is sort of a simplistic false rendering view, but it shows that the 3-dimensional framework is really serving to help to mitigate the direct sunlight getting into the space.
Okay, so we use the samples with the same terracotta body so that we could test the absorption and evaporation in order to just know what we were dealing with when we got here, um, and to get a sense of what kind of temperature differences we might be looking at. We learned that the water absorbed very quickly. So it absorbed in the first minute what it wound up absorbing over an hour. Maybe gained a little bit more, but it absorbs very fast. So that means that we can put a water system with our terracotta screen wall and only run it for a short period, and the wall will become fully saturated. And the evaporation was a much longer time frame. So we didn't sit with the samples until they were fully evaporated. That is on the to-do list of next steps, but we stayed with it for a couple hours, and the wet terracotta is already lower temperature, and then it just starts to fall off after a couple hours, even more. So let's see. Yesterday, so Pamela lent us her thermal camera. Thank you very much. We need Pamela for the full analysis, but it did help us to validate some of what we were getting from the infrared thermometer. And we were testing the saturated system as it was evaporating over time and testing it back to a dry tile that was just sitting off to the side.
Could actually feel the coolness coming off of the wall when you stood next to it. I don't know if some of you might have been there, and it was a really hot day. When you walk by, you could feel the cool.
Let's see. Oh, okay. Is there a video on this one?
Yeah, this one. Yeah, this one.
Okay. Well, we did by the end of 3 hours, we measured 70 degrees on the tile, and on the wet tile, and 90 on the dry. So it was very similar to the 20-degree drop that you were seeing in the cladding panels. The ambient temperature around that time was 84 degrees. And yeah, it was very cool to the touch. One of the byproducts of the sun kind of coming into the water that was at the base was that we also had a little, kind of dance with the light in the water.
Oh, here on the image on the left, you can see that glazing effect that I talked about. So the top unit, of course, is glazed. The bottom's unglazed, but when the water starts to come down, it's almost like the glaze is then starting to follow the path of the water.
This is the backer rod that Brian had to install so that the water would actually flow properly. And we gained a new respect for the use of backer rod and the installation of backer rod.
Yeah. And the system is supposed to actually have mortar in the joints. It's a closed joint system. We didn't think that it was going to affect the water flow as much as it did. So, of course, we had to come back and seal those pieces.
Did I miss? Oh, let's see if this works. So we had Peter built the entire water system ahead of time in New Jersey and then shipped it here because he wasn't able to join us. But it worked really well. We got the water kind of distributed across the top. And the camera is a little shaky, but it's trying to follow what the water is doing. So it comes down and then it gets pumped back up the back spine and redistributed across the kind of rain hose. You can see the water moving down and through. So we saturated it for about a half hour.
Yeah, what you can start to see from this video too is that as you rotate around the mock-up, the view windows, and maybe you could go up and look at the mock-up, after the presentation, is as you start to look at it obliquely, the window aperture that you're looking out of in terms of vision is really quite open.
Mm-hmm. So the system really will perform at its, optimal condition in a dry, hot climate. So we wanted to do a case study that just helped to explore the scale of this, and we were setting it in Tucson, Arizona.
Yeah, so we just did some vignettes on, what this could look like if it was clad over a theoretical or hypothetical building. So this is just showing an opening where it could be more of a screen wall with a back opaque surface, and then transition out into something that's more open screen wall with exterior courtyard behind it. We wanted to, look at some different conditions. So we said, what does the top look like? So we imagine what that top form could be to resolve itself. In the mock-up, it's sort of unresolved and sort of an infinite edge. But we think there could be some kind of cap that happens there, maybe something that can conceal the water distribution system. And then just studying the corner, what really happens there. And where we ended up was that you just basically take one of the units and cut it in a 45 and it miters well and marries with the rest of the apertures that are happening throughout the system. Just a day and a quick flip to night, if it as it turns to night, then it starts to glow from within. And this is an interview showing that, the lack of cable system or the lack of or the minimization of the amount of struts that need to come back to the building. As Amy mentioned, I think it can span 20 feet self-supporting. So every 2 floors, you could have a relieving angle, but and the floors in between, it could be very much open and a three-dimensional terracotta screen in your vision field. And the same goes for, in an exterior court condition.
We're going to install this in mix patio.
So that's it. And like everybody else, and we express our thanks, but we wanted to do it again. So thank you, everybody, including everybody in this room and our honorary team members.
Okay, questions?
Thank you very much for the presentation, the design. I really love the pattern and how all of a sudden the sun shading system has depth and it's perforated, and how the glazes of the terracotta become part of reflecting the light. And also you can see how the water would flow even just by looking at the pattern. But I'm wondering, in summer, like what you wanted to act for the urban heat island effect, like you would have to have constant water flow, right? Or not? How have you imagined it?
No, it's cooling during the evaporation. So it's not cooling because it's getting wet. It's cooling because it's drying. So I mean, we have to do scale the studies, but it seems like it can be fully saturated in less than an hour and it'd be evaporating over 12 hours.
Yeah, but depending, because if the sun directly is hitting the panels, it would dry much faster.
Yeah.
Okay, because I was thinking that you would have to have constant water flow, and I was thinking in terms of energy that you would have water tanks, and then the system starts becoming complicated than how smart it is already by its design.
No, I think that is the inherent efficiency of terracotta.
Okay, great. Thank you.
Thank you. Sure.
This isn't really a question, but as much as it is a comment. But I thought your design was very fascinating. As a student, I was it really reminded me of those like anti sort of like, because birds clash into windows all the time, and so this design has really been like fascinating because it helps avoid birds clashing into the windows. I have one quick question though. How do you feel about sort of like maybe like if something were to inhabit this sort of like structure and wall?
Well, there was a bee that joined us really early in the classes, and it wouldn't go away. So, but even with the bee coming to visit, we took several photos. I think that would be something really great to create a habitat. I think other past ACAW entries had done something that, incorporated habitat in terms of, I think bird homes and maybe some other pollinators. It would be really cool to think about some pads are about water flow and some pads are about habitat. And I think, it could be a system that doesn't have to be all one thing. I think this system, when we look at it, and even when we mapped it on that case study, if it's too relentless, it could become a little overwhelming and sort of redundant. So, I think so the variation in its visual quality, how we scale it is one thing we explore, but also in how it functions. So like you said, maybe some is about evaporative cooling, but others could be about natural habitat.
Thank you.
Any other?
I know.
Yeah, yeah, that'd be cool. That'd be cool. So, yeah, quick question. There's, I think, an interesting ventilation component to this too, right? It's like that also with the Benish design, when you have that evaporation going on, you get a temperature differential. And it might even be opportunities to amplify that air movement, which is going to amplify the evaporation, which is going to, increase the cooling. CFD analysis or something might show something like that. But, yeah, it seems like an opportunity.
Yeah, actually, is Peter texting you right now? I forgot. That was one of the.
He's texting you about that.
No, that was a driver in the design thinking too, and creating a form that we thought could actually help air move through the system. So yeah, I think more analysis like that would be great and would also probably help us and tweak the geometry.
Yeah, and you think about the water going down and the air going basically horizontal and how that intersects each other and creates the form would be really cool. Not unlike, I think, the UN studio, how they use all those forces to shape the way that their panel worked. I think that, the same thing could happen for these cells.
Oh.
I think this is beautiful. It's really, really clever and very creative. But with due respect to the law of unintended consequences, birds, pigeons, or something would make cleaning of the building facade pretty difficult. I don't know if you've thought about that or not, but the other thing is, or replacing a window. Nickel sulfide inclusions, and bang, there goes the window. How do you replace it if it hasn't been installed from the inside?
Mm-hmm.
That's a concern, but also how do you, in front of these breaks for some reason or another, how do you replace any individual unit in that beautiful facade?
Yeah. And we were just talking about that, especially when, the idea of disassembly came up, I think in the previous discussions, it would have to be thinking out of how these things interlock with each other, what their connection is, the biscuit, what the outrigger connection is. If we can design it in a way that's just as innovative as sort of the clip system that Boston Valley has come up with. We saw that demonstration where you can remove mid panels and replace them quite easily. It would have to be something like that. But in terms of glass changing, I think we'd either have to have enough space so that you could do the glass replacement, or like you mentioned, it has to be interior glazed, and maintenance would also, have to be addressed either through spacing it out enough so that somebody could drop down and maintain it, or you keep it to a certain height level so it's easier to maintain from the ground.
Along the same lines, and this will be the last question of mine anyway. But somebody could climb this too. I mean, that's a problem they had with the New York Times building.
True.
That would not be probably that difficult.
Yeah. That was part of our design intent.
Yes. Jungle gym as well. Thank you very much.
Thank you.
Thank you.